Hi, everybody. We are going to examine what was covered in Algebra 2, Week 3, which is now Unit 1, Topic 2, SLT 6, Graph Radical Functions Expressed Symbolically and Show Key Features of the Graph, looking at quadratics and roots and square roots, and Graph Radical Functions Expressed Symbolically and Showing Key Features of the Graph, looking at cubics and cube roots. So as we mentioned, we are now entering into Unit 1, Topic 2. So let's consider the equation y equals x squared. We can find some points in the graph that are seen here, and we can see some points on the inverse of the graph. Remembering that a point xy on an original function is the point yx on the inverse. So here we have the purple dots are representing f of x equals x squared, and the green dots are representing the inverse of f of x, which is root x. Does the inverse graph represent a function? Why or why not? In this case, because one value of x has multiple values of y, we would say that the square root of x, as written like this, as graphed like this, would not be a function. However, if we were to restrict the domain of y equals x squared to just the positive numbers greater than or equal to 0, then its inverse would be a function because you would only have the part going above the x-axis and not the part below the x-axis. Let's consider transformations of square root functions. Consider the following equation: y equals the square root of x plus 3 minus 2 as a transformation of y equals the square root of x. The red is the graph of y equals square root of x, and the blue is the graph of y equals x plus 3 minus 2. Notice how the transformation works. From the point, this key point here, 0, 0, is moved 3 to the left and down 2. And that could be applied for every single point on the graph. Now we're going to look at cube functions. So consider f of x equals x cubed. We're going to find some points on this graph here, the original function, and we're going to then similarly find points on the inverse function. Again, the point xy on the original is flipped as the point yx on the inverse. Here we have the purple graph, which is a graph for f of x equals x cubed, and the green graph, which is the inverse of f of x equals the cube root of x. In this case, does the inverse graph represent a function? Why or why not? Well, unlike the square root function, with the cube root, there is no situation where an x value has more than one y value. So yes, the cube root would be considered a function. Let's take a look at transformations of cube roots. So consider the equation f of x equals the cube root of x minus 3 plus 1. The graph here in red is the original f of x equals cube root of x. And again, we can look at the key points. Here's a point 0, 0. In this case, it moved 3 to the right and up 1. And that happened with every single other point. So here we have a point -2 here. That point is moved up over 3 and up 1 to there. Thank you for watching this video. Hopefully you have a better understanding of square roots and cube roots and their transformations.